Hey there, if you've spent any time offshore, you know, dynamic positioning isn't just some high-tech buzzword, it's the backbone of safe, efficient operations in some of the world's harshest environments. But what really keeps a DP vessel steady when the stakes are sky-high? It's all about redundancy. So today, I'm breaking down how redundancy in DP2 and DP3 systems keeps offshore vessels safe, and why it matters for every operator out there. First up, what does redundancy even mean in this world? Simply put, it's having backup for your backups. If a critical part fails, you've got another ready to go, and operations don't skip a beat. In DP systems, redundancy is built everywhere. Power, propulsion, computers, sensors, communications, you name it. The more layers of redundancy, the higher the DP class. Let's talk classes. DP1 is for low-risk jobs with no real backups. If something fails, you could lose position. Not great for anything critical. DP2 is a step up. Here, every critical system has a backup. Media group, dual DP computers in control room, split switchboards and thruster systems on vessel at its stock at a distribute_equally, dual DP control computers, dual power systems, at least 3 independent position reference systems, multiple heading sensors. Even your thrusters are split into independent groups fed by separate switchboards. The idea? If any single component bites the dust, you keep your place. But here's the catch, in DP2, there's no physical separation, so a fire or flood in the wrong spot, let's say a main switchboard room, could still take you out. That's where DP3 comes in. DP3 is designed for the highest risk jobs, think drilling rigs or accommodation ships where losing position isn't an option. With DP3 you get media group, triple redundant computers on vessel bridge, separate engine rooms and protected cable trays at its stock at a distribute_equally, triple redundant DP computers, split engine rooms, switchboards and different fire zones. All your cables run through protected areas, even the communication networks are doubled up. Each system is isolated so a fire or flood in one compartment doesn't affect the others. FMEA, the Failure Modes and Effects Analysis, covers not just equipment but what happens if the whole room goes down. Now, software plays a massive role. On DP2 and DP3 vessels, the DP control system is constantly scanning for faults. If a sensor fails, if a thruster reports an error, or if there's a power dip, it knows, and it reacts fast. Alarms pop up, automatic changeover kicks in, and redundancy logic, like 2 out of 3 voting for position references, keeps things steady. Operators, or DPOs, train for these moments. Media group, DPOs training in simulator, crew following emergency checklist on bridge at its stock at it distribute_equally, following checklists, using fallback procedures, stepping in manually if needed. Bottom line, redundancy in DP2 and DP3 isn't just a checklist item, it's a philosophy. It's what lets us operate safely when the margin for error is razor thin. Whether you're diving, lifting, or drilling deep, redundancy ensures reliability, and reliability keeps everyone safe. Stay sharp out there.